All right, guys. So to start this section, I'm taking you all the way back to the very first unit we did together to start the semester. And that's all your properties of exponents. They're all coming into play again, but now our exponents are fractions. Okay, so we're going to have to use all these properties. All right, so the first property is just telling you when you multiply, what do you do with your exponents? You add them. So if I have fractions, if you suck at fractions, type them in your calculator, okay? Just use the calculator. So it doesn't have to be a variable per se, back table. It can be just like a number as a base. So if they're both 8s, it's going to stay an 8, and you'll just add 1/3 plus 2/3, which is 1, or 3/3, which is 1, so it's just 8. Okay, but if it's a multiplication problem, you add your exponents. All right, and then we have, if you're distributing, what operation do you always do when you distribute? You multiply. So same idea with exponents. Do exponents ever go to the base number? No, they only go to other exponents. Even unspoken exponents, what if it's not there, what is it? It's a 1, and they go to those as well, okay? But yeah, they get multiplied. So same thing here. It goes 4 times the half, which is half of 4 is 2, so 5 squared then is 25. Same thing if there's more than one thing in here, it's going to distribute to both of them. So the half gets taken to the 4. Now that doesn't make half of 4. It's 4 to the 1/2 power, 5 to the 1/2 power. These are not same bases, so they don't go together, but I can do, that's the square root of 4, which is 2. That's about as far as you can go. Negative exponents, remember those? Negative exponents move. So if it's negative on top, you have to move it to the bottom to make it positive. What if it's negative on the bottom? Moves back to the top. Yep. So that's the same idea there. If it's division, you subtract. Yep. So in this example, they're both 7s, so it keeps the base of 7, and it's always top minus bottom. Okay. So 3/2 minus 1/2 is 2/2, which is just 1, so it's just 7. All right. And same thing here. If I'm distributing to a fraction, it still goes top and bottom. All right, so number 1, write each expression in simplest form. This is where students start to fall apart. Maybe not necessarily these 3 examples, but like this whole process, and the more and more stuff I give you and the bigger the problems get, people don't know where to go. A lot of times they switch into radical form too early and they're like, I don't know what to do with this. Okay, so you want to put everything together you can first, like with your exponent properties, and then when you've done everything you think you can, then flip it to a radical and see if anything simplifies. Okay? So 18 to the 1/3 times 18 to the 1/3 times 18 to the 1/3. What's my common base? 18. I know where you were going with that. And then what do I do with the exponents? 1/3 plus 1/3 plus 1/3 is 3/3, which is 1. So it's just 18. What about number 2? The common base is 3. What do we do with our exponents? Add 1/4 plus 1/4 plus 1/4 plus 1/4. 4/4, which is 1, so it's just 3. All right, so these were nice. They worked out nice, pretty numbers. I didn't have to do anything. But you know that doesn't always happen. So here my common base is B. What do I do with their exponents? I add 1/5 plus 1/5 plus 1/5 is 3/5. Are you allowed to leave a fraction for an exponent? No. So if you ever think you're done, ready to circle your answer, and there's a fraction for an exponent, you're not done. You got to flip it back into radicals. So what root is this? 5th. So that's the 5th root of v to the 3rd. Can I take a group of 5 from there? So then I'm done. But if I could have taken it, then yeah, you would have kept going and simplified that. Okay, so you want to put everything together you can first, then flip it to radical form. Don't flip them early, you're not going to know what to do with it. All right, number 4. What's my common base? A. Now this is where, if you're not great with fractions, you're going to want to grab a calculator. Because if you're adding, you'd have to have a common denominator if you're going to do them in your head. So it's going to be easier to just grab your calculator. Let's type them in. What is 1/2 plus 1/6 plus 1/9? 7/9? You guys got that? Okay, so all we did was add 1/2 plus 1/6 plus 1/9 equals out to be 7/9. Am I good? Do I stop there? No. Flip it into radical form. What root is it? The 9th root of a to the 7th. Can I take a group of 9? No. So I'm done. But you always want to try to take the groups out if you can. Number 5, common base, 2. Add those exponents, 3/4 plus 1/5, 19/20. Make sure, again, you're watching your writing, that your exponent looks like an exponent. All right? Flip that into radical form. What root? 20th root of 2 to the 19th. Can I take a group of 20 out? No. Should I leave 2 to the 19th? What is 2 to the 19th? If the number is huge, you can leave it. But if it's not too huge, we can actually write it out. It's very big, then stop here. If it's huge, leave it. Now, if you have like 5 squared, you better not leave 5 squared. You got to write 25, okay? But if they're huge, like that number got real big, just leave it with exponents. What about 6? It is a multiplication problem. The exponent is not on the outside of the parentheses, so it doesn't distribute. You would still add the exponents on the common stuff. What is the common base? M is the common base. So what do you do with 6 and 2? You multiply. Right? If it's not a common base, you actually go ahead and multiply those together or divide if it's a fraction, like whatever the problem looks like. But you got to think, what's the common base? Then that stays a base, and then you do your exponents on that. So what's 1/3 plus 3/4? 13/12. You guys with me so far? Questions? So we know we cannot leave it with a fraction for an exponent. So we need to flip it. Where does that 12 go? This 12. It goes outside, right? Because what's the exponent on the 12? It's just a 1, right? So that 12 stays outside. And then what root is it? 12th root of m 13. Can I take a group of 12 from there? Yes. How many groups of 12? 1. So that's m to the first, right? Because I could take one group out. And then how many would be left inside? There'd be 1 left over. Don't forget your little 12 as your index, though. That index doesn't change. If you don't know what I just did, please ask, and I'll make sure I explain. This 12? Are you okay that it came from 6 times 2 here? No. Nope, that doesn't go under the radical. Now, if there had been a parenthesis around the 12m, and then it would have gone under. We okay? Good. Number 7, 27 to the 1/9 to the 9th. That's distributing. Do you see how the exponent is outside the parenthesis? So then it's going to distribute in, and this is where some students really kind of fall apart because they try to multiply it to everything. It only multiplies to the exponents. Yeah. So what's 9 times 1/9? It's just 1, yeah. So 27 to the first, which is just 27. Okay, number 8, so what do I do with those exponents? Distribute them in. So the base is still a 3. And then what's 5 times 4/5? That is 4. Should I leave it 3 to the 4th, or is that a pretty decent number? It's 81. Yeah, let's change that one. Now, if you're in the millions, I mean, by all means, leave it as an exponent. And then number 9, what do I do with that? Distribute to both exponents. So the base of 2 stays a 2. Then what's 9 times 1/3 is 3.
I think you're all at once. You can't do that.
No. Yeah, the calculator's going to be smarter than you want it to be. All right, and then we have n is the base, and that's 2. Stop there or keep going? What's 2 to the third? That's 8. And then n squared. Does anything need to be flipped to a radical? No, there's no fractions for exponents or anything, so I'm okay. Are we doing okay so far? They've been pretty basic to this point. People start falling apart when I get a lot of stuff in them. They're coming. Yeah, they're coming. One at a time, though, guys. So number 10. What do you do first? Distribute to what? What are the exponents? Thank you. Yeah, you have an exponent here for 1, you have a 1 there, and then you have a 1/4. I'm going to strongly suggest probably the grand majority of you are going to need to write those 1s in there. Okay, just because otherwise you don't see them. If you don't see them, you don't think about them. All right, so this gets distributed to all 3 of my exponents. The base of 5 stays a 5, and then 1 times 2 is 2. And I have a base of an x, 1 times 2. And then my base of a y, 1/4 times 2 is 1/2. Okay, so at that step, all I did was distribute to all of my exponents. Okay, anything to clean up from there? Yeah, 5 squared is 25. Anything to clean up with x squared? No, you can say x squared. What does y to the 1/2 mean? The square root of y to the first, or just y? Can I take a group of 2 from my y's? No, so I am done. But you see how we went through that kind of one piece at a time, right? Just kind of distribute to everything and then try to just simplify each part as much as you can. Okay? How about 11? What do you do with those exponents? You actually have some options. You could move that 1/2 up because it's negative. I'm lazy. I don't like to do it in this step, but you can. Totally an option. What's the other option? What's the rule with division? You subtract them. So what's my common base? And then what's 2 minus a -1/2? 2.5. 2.5 for an exponent, is that fun? Be 5/2. And again, you can switch that. If you're not sure how to switch on your calculator from mixed numbers to improper, make sure you ask, and I'll show you how to do that. Okay, are we okay? We good? All right, and then let's flip that into radical form. Of v to the 5th. And then can you take a group of 2 out? I can take 2 groups out. So 2 group, ooh, you said u and I just wrote a u. So 2 groups out, so v squared. How many would be left? Just 1. And again, if you're somebody that's still like, it's hard to do that like mentally, write it out. It's totally fine. Right, I have 5 v's and I'm taking groups of 2. There's 1 group, 2 groups, and 1 left. Right, so the groups come out, leftovers go in the fridge. Stick them in. I like that. I came up with that today. It works. All right, so what about 12? Say that again. Multiply what? I'm not going to multiply it, but I'm going to move it. Yeah, like right now, like on this one, I had v's on top and bottom, so I just went ahead and put them together. I don't have any bases that are the same here. So the only thing I need to start with is I have a negative exponent. It's on the bottom. Let's move it up top. So 6x. What happens to that exponent when I move it up? Just positive. That's all it does. Switches it to a positive. You can put it over 1 if you want. You don't have to. Just know that it's all on top. And then can I leave it like that? I have a fraction for an exponent, so you got to switch that. So what happens? Where's the 6 go? Outside. Where's the x go? Outside. Where's the y go? It's going to go under here. What root is it? Square root of y to the 3rd. Again, some of you can probably do a little more in one step, and that's fine. I'm going to go very step by step for you. So I just switched it back into radical form. And then can I take a group of 2? Yeah, how many? 1. So 6x, y. And then how many is left over? 1 left over. You guys doing good. It went under the radical because it's exponent was a fraction. Yes, whatever that exponent is on, that's attached. You can't take that apart. Yeah, whatever it's right next to. All right, you guys are doing good. Ah, they're starting to get bigger. 13, yeah, we'll distribute first. Okay, so if I distribute, I have my base is x. What's 2/3 times negative 12? That is negative 8. And then I have a base of y. We'll distribute here. Negative 1/4 times negative 12. It is a positive 3. And again, use your calculator. If you're not sure, type it in. Mata, you okay? There's a lovely look on your face right there. All right, so we distributed. Distributing is multiplying, so I just multiplied those. And I got this. And then what needs to happen here? Good. So this x has a negative exponent. We've got to move that whole piece down. So the y is good where he's at, but the x needs to move down to the bottom, and then that becomes positive 8. Yeah. You don't have any common bases to put together. I don't have any fractions for exponents. I'm good. Yeah.
That's it.
You know, you're kind of right though. Like you get moving with it, and you're like, how many steps am I going to have to take to get through this? And there's no.
And it just stops like that.
Yeah, and you're like, sweet, I did it. I made it to the end of the hallway. I like that analogy. I like it. A dark hallway, yeah. Like you're blind, right? You're feeling your way through. That's kind of what we're doing. Sometimes with one step, you're like, hey, I made it to the end. And sometimes you're like, holy crap, I got to walk all the way down here with so many steps in this stupid problem, right? That's what it feels like. It's all right, I'm afraid of the dark, so I don't like him either. I'm afraid of the unknown. I don't like that. You don't know what's jumping out at you, right? All right, 14. What do we do first on 14? We distribute. So it's going to come up here, and it's going to go down there. It's going to go to everything inside of there. So on the top, my base is an m, 2/3 times 3. Yes, sorry, my red didn't say. I'm multiplying by this exponent and that one down there too. 1/3 times 3. One step into the hallway and I'm done. Yeah, there's no fractions for exponents. There's no negative exponents. There's no radicals for me to simplify. I'm done. But can you see why students struggle though? Like, there's no great answer of how many steps it's going to take you. You just got to kind of keep going one step at a time until you find it. I hope so too. So 15, what do you do first on 15? Distribute to what? What are the exponents? 1, 8, and 20. See the 16? There's a 1 there, an 8, and a 20. So guys, some of you get it stuck in your head like 16x to the 8th is one piece. They're not, okay? I have a 16 and I have an x to the 8th. So they are like separate pieces. They're not like glued together. All right, so we're going to distribute. Hopefully me asking you what these exponents are all the time will help you to not forget those little ones. So 1 times 1/4 is 1/4. Distribute here. 8 times 1/4. Going to be x squared. And it goes to the bottom as well. 20 times 1/4 is 5. So there's the first step. Good. Now we're going to flip that 16 back into a radical. So that becomes the 4th root of 16. Where does the x squared go? Outside. Should I write it in front or should I write it behind? In front. Now, it's not necessarily wrong if it's after, but if your radical got a little long, it looked like it was under it, it would be wrong. All right, and then my y to the 5th still on the bottom. Can I do the 4th root of 16? If you knew that it was perfect, yeah, you could have. Sometimes it's just easier for people to see it that way. It's 2, yeah. 4th root of 16 is 2, so you're going to have 2x squared over y to the 5th. I had to walk further down the hallway. Yeah, Izzy? If you knew that that was perfect from the beginning, yeah, that's fine. Yeah, that's fine. Yep. I won't count you off for that. Because its exponent was a fraction? Mm-hmm. Yep. And that bottom number is telling you what root it is. Yeah, but whatever that fraction exponent is on, that's the piece that's underneath. If you have a lunch, yes. All right, guys. They're getting even prettier. So 16, what did you just say? Yes, you can. Yeah. Now, biggest mistakes people make, a 36 and a 9. They're like, oh, I subtract them, right? Thank you. What do you subtract? Exponents. Those are not exponents. This, if I had 36 over 9 as a fraction, you would just divide and tell me it's 4. That's 4. Right, what do I do with the d's? They don't cancel. What do you do with their exponents? You subtract them. So what's 1/2 minus 4/5? Negative 3 over 10? If they were just a d, they would cancel. But they have exponents. Yeah, so you have to deal with your exponent properties. The common base of d just tells you that they go together. No. Honestly, I don't know what I would put on the colored paper. Follow your exponent rules? I mean, that's about all I'd write on it. Again, take your steps down that dark hallway. They're all letters and numbers. There you go. All right, so at this point, all I did was I took my big coefficients and divided them. And then these d's matched bases, it's division, so you subtract. That's where I'm at. Okay? Negative exponent, what do I do? What does the negative exponent attach itself to? The d. So where does the 4 go? On top. 4 stays on top, because its exponent is a 1. It's not negative. This moves to the bottom, d to the 3/10. This problem is fantastic, by the way. He's seeing the future. All right, let's go nice and slow. Hold on, let's go nice and slow. Dakota?
Why is it all of a sudden a fraction again? I thought it just came out.
We had a negative exponent. To make it positive, you have to move it to the bottom.
Okay.
Yeah, so right now the 4 just had a 1, so he stays because his exponent was positive. Negative exponent moves it. He was on top, so he just moved to the bottom. All right, we're at a point. Do you have anything else common or anything to put together? Once we've exhausted every other option, and you still have a fraction, we got to flip it to a radical. Yes, because it was negative, so I moved it. And then what root is this? The 10th root of d to the 3rd. Don't say anything. Just make sure everybody's okay to this point. So again, negative exponent, so it got moved to the bottom. And now I still have a fraction for an exponent, so it's going to flip itself back into radical form. Can I take a group of 10? Can I leave a radical in the bottom? So we need to rationalize. That means we multiply the top and bottom by the 10th root of d to the 7th. Remember, this index tells me how many I want in a group, right? I already have 3. I need 7 more to give me 10. Remember this from last week? Yeah. And whatever I did to the bottom, we have to do to the top. So let's talk through this again, make sure everybody's on the same page. Okay. So, guys, so since I still had a fraction for an exponent, that tells me to flip it back into radical form. So the bottom number, 10th root of d to the 3rd. At this point, I can't do anything else with it, but I can't leave a radical on the bottom. So that means we have to rationalize. My index is 10, so that means I want 10 of whatever else is in here. I already had 3 d's. I need 7 more so that I create something, yes, so that I have the 10th root of d to the 10th on the bottom, because I'm going to want those to cancel out. on the top, can I actually multiply anything here? No, so that's just going to be 4 times the 10th root of d to the 7th. Of course. So what did I just create on the bottom? What's the 10th root of d to the 10th? It's just d. Yep, so we have 4 times the 10th root of d to the 7th over d. So this is where students start to fall apart. Because this took everything from this chapter and put it all in one problem. So how far down the hall did I have to go? I went all the way down the hallway this time. It was a long hallway. And that's why we're going to practice. So I'm teaching you all this today. You're going to have homework tonight to practice. And then tomorrow during class, we're just doing an activity for you to practice more before we move on to the next part. Okay? You have a test on Monday. Probably never. Honestly, it really is. I think I've talked to you about the marathon running example, right? I run for exercise, but do I plan on running marathons? Heck no. No way. I hate running. I only do it because it's good exercise. But same thing. This is exercise for your brain. It makes your brain function better. All right. Come on, guys. We're doing good. Let's finish this up so you can have some time to work today, okay? You're in here till, we're almost out of time. 17. Now, do you notice you have common bases? Okay, so you're always looking if you need to distribute something, which we don't, and then do you have common stuff? Yeah, stuff. Since I have an m on top and an m on bottom, what do I do with their exponents? You subtract, and it's always top minus bottom, right? We always work our way down. So what is half minus 1/8? Thank you. All right, and then I have common bases of an n. What do I do with their exponents? So what's 5/8 minus 1/4? 3/8. Okay, so I put my common stuff together, and I'm looking at that. Is that a good answer? Am I allowed to leave fractions for exponents? No. Okay, well, what root do they go under? Can they go under together? Yeah, since they're both 8th roots, I can put them under together. Okay, you could write this 2 different ways. So you said mn cubed, or, yes, whoa, I can't make an 8. The 8th root of m cubed, n cubed. Either way is fine. But now, what if they had different denominators and they weren't both an 8? Then they'd be separate radicals. Can I take a group of 8 from there? What do you mean? Yeah, if this had been a 3 and that had been the 8, then yeah, you could have. That's why you got to really stop and like say it out loud. Can I take a group of 8? No, I can't. Okay. Yeah, it's as far as I can go. No negative exponents, no fractions for exponents left over, no common bases left. It just gets overwhelming when there's so many different styles of problems. Like some of them are really easy, one step and you're done, and some of them, like this one, took us forever. Okay.